conference is an excellent place to learn new stuff, dip your toe into new things, meet new people, and generally have fun.
What I like most about PASS is the community. It's really something special.
First impression is like, wow.
Family, the SQL family. SQL servers what brought us together, but then we form bonds well outside that that keep us together.
Meet people, get the session recordings because you can't see everything. But yeah, make friends and enjoy.
If you've never been to PASS, you need to come to PASS. There isn't anything bigger or better than this anywhere. It is completely awesome.
Please welcome PASS Executive Vice President of Finance, Wendy Pastrick.
Good morning. I'm excited to see everyone here at Day 2 of PASS Summit. I hope you all had an amazing day of learning yesterday. Last night's exhibitor reception was so much fun. How about a round of applause for our exhibitors? Right? If you missed talking to any of them yesterday, please make sure you stop by their booth and say hello. They did come here to help you, and you never know, you might even win some great prizes. One of the best things about attending networking events like the exhibitor reception is having the opportunity to connect with old friends and make some new ones. There are many opportunities to do this throughout the week, and you can go to game night, you can hang out at the tap room or your hotel lobby. Well, my personal favorite, SQL karaoke. That started off as a small get-together with a couple of friends, and it has become an annual tradition now that anyone can take part in. You might have recognized the gentleman in the front of that slide from yesterday. I mean, really, just because I love going out and singing Bohemian Rhapsody at the top of my lungs, the real reason that we all come here is to get connected with our data community and to develop relationships that can take us to the next level of our data careers. These networking opportunities are truly what sets this event apart from all other data conferences. So please, get out there, have some fun, make the most out of your PASS Summit experience. Over the last 2 days, we have already had 82 sessions. That is over 197 hours of expert-led training. Is your brain full yet? Yeah, all right. Well, I hope you have had plenty of moments of genius that you can take back right to your office on Monday morning, and there's lots more today and tomorrow. As we look to the future of PASS, it's been great to look back and celebrate the incredible things we've achieved as a community through our V20 stories. The foundation we've built over almost 20 years gives us a stable platform to expand our audiences and evolve our programs even further in the years to come. With a community of 300,000 members, 185 countries, there are more opportunities than ever to connect with data professionals from all around the world. Of course, this is only possible because of all of you, the developers, DBAs, architects, BI professionals, analysts, IT pros, technical directors, managers, data scientists, and more, who, through all of our collaboration, help each other overcome obstacles every single day. As the Executive Vice President of Finance, it's important to know where our money comes from and where it's going. This is the boring part. This year, I wanted to do something a little different and show you how we make financial decisions for PASS. Since we're a community of data professionals, we also want to apply data-driven principles to our decision-making process. By leveraging tools like Power BI to give us clear success indicators, we can support our decisions with data and predict our growth throughout the year. These tools help us tell where our members are located, which past programs they're participating in, and whether or not they're attending paid events like Past Summit. By having this data at our fingertips, we can make data-driven decisions about where we should be spending our money. So where is our money coming from? Oh boy. All right. Well, at first I was afraid, I was petrified, because now I have to speak to these financial slides. And there's oh so many numbers and some infographics too. So here is my attempt to make this fun for you. Now here we go. Our revenue. Here's all the money we take in that we can spend on you. It comes from different places, some it's 95%. And now I'm gonna show you just where all that money went. It went to you, community. We spent a lot to offer training opportunities. All these events we put on you for you every year. Right? It takes lots of work, and they don't just happen here. So many groups, so many ways, and every weekend somewhere there's a sequel Saturday. There were some times we wondered if we couldn't how, but I'm here to tell you that the budget's balanced now, so there you go. Thank you. Come on, that has to be one of the most fun financial presentations you've ever had, right? Later tonight, there'll be more, I'm sure. So we are only able to achieve what we can do as an organization with the help of volunteers and people like you. You are helping by being here and engaging with PASS and our sponsors. Each and every one of you is contributing to the future of PASS, so thank you. And now I would like to welcome the Vice President of Marketing, Tim Ford, to the stage.
Thanks. Good morning, everybody. Just so you know, we've actually flipped a coin backstage to see who was going to sing, and we all won. Trust me. Anyway, good morning. It's great to be with you here at day 2 of PASS Summit V20. I hope you've been enjoying the sessions and getting the most out of your PASS Summit experience so far. One of the best things about attending PASS Summit is the networking. And over the last 2 days, it's been inspiring to see so many new PASS members. Over 40% of you attending this year are coming here for the very first time. And I hope that this experience kickstarts the next step in your data career. I still remember my first PASS Summit back in 2002, which I think was actually before my Zune ever, got released. And I remember the impact that it had on me. It was really early in my data career, and I sat in the back of the room for the sessions and for the keynote, and finally I went ahead and kicked up the courage to start talking to people, and over the course of the week I ended up meeting with a couple of volunteers that were starting up something called SIGs, or Special Interest Groups. One thing led to another, and next thing you know, I was volunteering to run the DBA SIG. You might know that now as the DBA Virtual Chapter. From there, I would go on to serve the program committee, organize the first 2 sequel Saturdays in my hometown of Kalamazoo, Michigan. What? No applause? Damn. Thank you. And host the annual Quiz Bowl before taking on the role that I've got now on the PASS Board of Directors. Now, there are those moments we look back and say, that changed my life. And by putting myself out there, I went from being a shy first-timer with a paralyzing fear of public speaking to achieving things in my data career that I never thought possible. And here, 16 years later, I stand in front of thousands of you here and online, fellow PASS members, celebrating our 20th summit. Thanks. So whether you're new to PASS or been a member since day one, I encourage you to get involved and take advantage of the volunteering opportunities that are available through PASS. By volunteering and connecting with your community, you're not only helping others, but you're also growing your own skills and your own experience and network in return. Can I please get a round of applause for all of our panelists, facilitators, volunteers, and speakers who dedicate so much of their time and energy into PASS events throughout the year. Now, there are a lot of members of the Sequel family who have, through a commitment of volunteering and friendship and community over the years, have left a lasting impression on us here at PASS. I'd like to observe a moment of silence for those members who are unfortunately no longer with us. Thank you. PASS is a community that prides itself on supporting and embracing our diverse membership, and it's been exciting to see this growth at PASS over the last 20 summits. Through initiatives like the Women in Technology virtual group and PASS Summit Luncheon, along with increasing female leadership in PASS-hosted events, webinars, and online events, we're honored to be part of the growing Women in Technology movement around the world. Yes, come on. Matter of fact, we've been doing this since 2003. The Women in Technology Luncheon has been an important part of the PASS Summit since then. And during today's event, Lori Bingham, T-Mobile's Director of Technology, Engineering Project Management, will be sharing how you can mobilize your own grassroots movement to empower gender diversity in technology and your data community. That will be taking place right here today at 11:30. Our global membership has also increased, thanks to the tireless efforts of our volunteers, hosting events, creating opportunities in almost 200 countries. This has resulted in APAC and EMEA more than doubling in size, and LATAM almost quadrupled their membership ranks in just the last 5 years. That's an incredible achievement, and it wouldn't have happened without you. Our dedicated members across the world who volunteer their time connecting with others and participating in year-round events. Over the last 20 PASS Summits, the Microsoft platform has evolved continuously, and so too has the PASS Summit program. From the evolution of our content framework to the introduction of new session tracks in 2016 and inclusion of sessions focused on the developer and analyst, we constantly expand the program at PASS Summit to meet the growing technical demands of our members. I'm pleased to say that this trend continued this year with our first ever Get Focused hands-on pre-conference session covering source control management. I'd like to thank the program committee whose efforts have resulted in the amazing program that we have here this week. Thank you. In order to understand you better and make improvements that support your future, we need your feedback. The insights we collect from session evaluations, the membership survey, and directly from you help inform our year-round content strategy and the program here at PASS. Please take the time to fill out your session evaluations because the program committee uses this information in order to build out the amazing session offerings we have here at PASS Summit. The membership survey is also now open and will be for the duration of the event, so please take the time to complete this if you haven't done so already. You can find a link to the survey in any of the PASS Summit bulletins or on pass.org. If you have any questions on this or any other community-related questions, swing by the community zone. That's where PASS HQ staff will be there to assist you in any way possible. Speaking of the community zone, another way you can provide your feedback is attending the board Q&A today there at 5 p.m. Come by, talk to us. We'd love to hear from you. Missed a session? Maybe you were conflicted about 2 or 3 at the same time? Maybe you were trying to recover from last night's karaoke session. If so, take the time to stop by registration and order a copy of the recordings so that you can go back and catch all the things that you weren't able to see in the time that you had here. Speaker Idol is also taking place again this year, so make sure that you support your fellow community members as they hone their speaking skills and battle it out for a spot at next year's PASS Summit 2019. And now, I'd like to welcome to the stage Mark Souza and friends, who will be reflecting on the 20th PASS Summit and 25 years of SQL. After that, Raghu Ramakrishnan will come out and we'll talk about the future of SQL Server. Thank you.
All right. Good morning. First of all, PASS, congratulations. 20 PASS Summits. That's pretty awesome. And I'm one of the very few that actually attended all 20 of those summits, so it means a lot to me personally. But it's not our only celebration today. We are going to celebrate 25 years of Microsoft SQL Server, August 1993. And we thought it'd be pretty cool if we actually brought you back and take you through the journey. And to do this, I actually brought some very special friends. So my friends want to come on stage. Listen closely to these introductions, folks. First of all, Ron Sukup, the very first General Manager, Microsoft SQL Server, 1989.
Good morning.
A few of you probably recognize the second guy. Paul Flester was Senior Vice President of SQL Server from 1995 to 2005. Thank you. Those are the days that Microsoft went from a Office and Windows company to a database company. Paul, welcome.
Thank you very much.
Now, a few more of you recognize the next guy, Ted Kuhlman, Corporate Vice President from 2005 to 2014. Welcome, Ted. Thanks. Those are the days that we took SQL Server into the enterprise, you know, giving Oracle a little punch there, and then also our entry into the cloud. And of course, hopefully everybody recognizes that beautiful face, the latest and the greatest, the Corporate Vice President of Data Platform.
Hey, guys.
Rohan, thanks for coming. All right, let's sit down. By the way, they came out of retirement to show up today to spend time with us, so it's pretty awesome. Okay.
I'm not retired.
All right, Ron, obviously we're going to start with you, but there's some guys back in the lab from your era that want to say a few things, so let's take a look.
Fail over.
I started with SQL Server back in the OS2 days, 1.0 character-based.
Way back when, we actually put the software on these things called floppies. And this is actually one from 4.2.1.
I was a newbie out of college, and I had no idea what was going on. I was just in awe.
The first version of SQL Server I worked with is 4.2, and the optimizer is really straightforward.
It was so easy to tune. You just declared everything as a clustered index.
Always choose cluster index, 100% of the time.
And of course, version 6.0, none of this Visual Studio stuff. You had Enterprise Manager.
SQL 6.5, we took a shot at doing row-level locking. We introduced something called insert row-level locking, which was kind of the first journey.
And there was only about 17 of us. Our leader at the time was Ron Sukup, and believe it or not, at one of our ship parties, we actually found out that he could drink beer upside down.
Okay, Ron, we're going to start with you. And the obvious question, besides the drinking beer upside down thing, which we'll keep to after the keynote, how did this all get started?
Well, in 1989, I was working on mainframe databases, but the future seemed pretty clear when I realized you could support a pretty nice work group, say 20 concurrent transactional users with a PC database backend. So I jumped at the chance to join the 5-person SQL Server team at Microsoft. And back then we ran on 16-bit OS2, but the server was actually surprisingly competent on a Intel 386 server with 2 megabytes of RAM. We shipped it on a floppy, as Mike showed. We compared very favorably to a Unix mini computer that was well north of $150,000. Now, unfortunately for us at the time, OS2 was a sales flop. However, in 1990, Microsoft released Windows 3.0, which was a mega hit in the industry. It was really a watershed. Now, we didn't run the server on Windows 3, but what we did smartly was right from the get-go, actually even before Windows 3 shipped, we provided a Win16 DLL so you could write nice graphical Windows apps with SQL Server on the back end. Now, not too many people were buying OS2, but if you were buying OS2, it was probably to run SQL Server. That sales failure of OS2 and the huge hit of Windows 3 caused IBM and Microsoft to split around operating systems. Microsoft went off and developed a new system called Windows NT, Windows Server today, and the Microsoft bigwigs at the time, Steve Ballmer and Paul Maritz, made it abundantly clear to me that my continued tenure at the company would depend on getting SQL Server on Windows NT very quickly and very well.
But that wasn't the dream. 4.2 was pretty big. That wasn't the dream. You had some big bets at the time. You had some big dreams. What was the dream at that point?
Well, we released 4.2 on NT in August of '93, within 30 days of NT itself shipping. And NT was a watershed for us because now we had a 32-bit OS, so we could address a lot of RAM, by that standpoint at least, not 2 megabytes anymore. We had multi-processor hardware. So we just dedicated ourselves to do the best job we could on NT. We didn't try to be portable in any way. If Windows NT had a feature like threads, Unix didn't have threads, we used them. So we separated ourselves from the Sybase co-development deal and just tried to do the best job we could. We were looking ahead towards a bigger release, though, what we called SQL 95 for 1995. The industry was openly skeptical, if not mocking. They called it SQL 1999 or SQL Infinity. But in the summer of 1995, we shipped version 6.0, and it was a hit. We had a lot of great features. We had true outer join support. We had proper relational constraints, replication in the box, graphical user interface. We plugged in the NT performance monitor. Those were all things that nobody else was doing, and we were giving it away. If the other companies were doing it, they were charging a lot. And then at that same time, that fall of 95, we released audited TPC-C benchmarks where we were doing 2,500 plus transactions per minute, which was 150% of the performance that Sybase was getting on a DEC mini computer. It was 140% of what IBM DB2 was doing on a RISC-based RS6000, and we were at a quarter of the price. So this was mind-boggling. It was a revolution. And then just a year later, we shipped 6.5 into beta. So that little group of 17 people was a little crackerjack team. I don't think we'd be here today without them. It was really a band of brothers and sisters.
All right, so let's move on to Paul. And Paul, we actually have a message from the guys in the lab about your era.
One of my favorite things in SQL 7 was having this long meeting, whether the create database should be kilobytes by default or megabytes by default. Lots of people are arguing no one will ever have a database that's a gigabyte, so we don't have to think about that.
I remember in a keynote with Paul Flessner in 2004, he declared it was humbling to bring down the internet.
One of my biggest memories of SQL Server was in 2003, the Slammer virus basically brought down the internet worldwide. I found myself on a conference call at my home with Billy Joe Murray, Paul Flessner, and David Campbell, showing them what was on the internet because they had no internet access.
The best part of SQL 2005 was the running bet we had as to when it would actually ship.
We were very ambitious. We took on a bunch of massive rewrites. I bit off more than I could chew. It was a massive disaster, and I became an infamous legend for a while.
One of my favorite features in SQL Server was actually DMVs, because I got really angry one day, closed my door for about 2 or 3 weeks, and then came out and had DMVs. And now they're used everywhere.
All right, Paul, so the external community doesn't know this, but internally you had this famous statement, and I think it was inspirational to, and one of the reasons SQL Server is so successful. So I'm going to share it with them, and I'd like you to comment on it.
Okay.
And you said, Oracle and DB2, they're running in this direction. We're not going to chase them. We're going to go in this direction and have them chase us. Can you talk a little bit about that?
Yeah, as Ron was alluding to, the company strategy was to basically change the economics of enterprise computing. And we knew we weren't going to get a lot of help from our competitors, IBM, Oracle. At that time, there was still Sybase and Informix. So we were going to have to kind of go it on our own. Leaving it up to them, they would have pigeonholed Windows down to the lowest part of the market, departmental servers, that sort of thing, so that they could reserve the high margin business in the data center, for their high-end product line. And, at the time, Ron, I think when Ron turned the product group over to me, we had 65 total in the entire group, something like that. And Oracle and DB2 were, hundreds, if not more, on their engineering staff. And Oracle was running Informix and Sybase in tight circles. They were adding all these bogus data types and, just crap that no one was using. And, they were just following and lapping it up. And we got this too, we got this too. So, I had 11 years of experience in IT prior to coming to Microsoft, and, just in theme with what the company was trying to do, we were really going to try to head down this road of lower total cost of ownership. Initially, Bill hated it. He thought it was, horribly not innovative. Bill's like, I'm out talking to executives all the time. They never talk about cost of ownership. I said, Bill, you're meeting with the CIO, and it's the meeting of their life. They're not going to talk about total cost of ownership, right? They're going to talk about some crazy thing that they're trying to do. Anyway, so we decided we had to, standing on the shoulders of the team that Ron built, which was a great team, we needed to sort of try to up the game again. And, we talked a lot about the hiring and how we had to do that. And this analogy between Hall of Famers and All-Stars. Hall of Famer knows everything about the game. They're great, but their best days of playing the game are a little behind them. We needed to hire a few of those guys who are good leaders and good managers, but we also needed to hire some all-stars. So we did hire a few Hall of Famers, Berenson and Spiro, notably Campbell and others. And they gave us some industry credibility and certainly helped us in our leadership ranks. But the most important thing they did was hire the beginnings to hire some really fantastic software engineers. And the world at that point was standing up and taking notice. But we still had a lot to do on the product.
And two defining releases, 7.0 and 2005. Just a couple tips on
Yeah, 7.0 was scary as heck. Oracle had done this fantastic job of educating the market that you had to have row-level locking. Every customer in the world thought they needed, I'd walk into a shop and there's one guy on the machine going, I need row-level locking. Really? And so, we finally gave up trying to say that, you didn't always need row-level locking. But Oracle was very clever in that because they knew in order for us to do row-level locking, we were going to have to do a lot of deep work in the storage engine and most likely change the on-disk structures. So the Sybase code base that Ron was working in was over 10 years old when we got it. It was built for single SMP Unix environments. It didn't always do well on Windows in certain environments, and we really wanted to kind of step out from that. And I think the industry thought, yeah, 2, maybe 3 releases, they can get the on-disk thing changed, which is the scariest thing in a database world where you have to unload the customer's database, reformat it, and put it back. Horrifying for everyone. And then change the storage engine deeply and then rewrite the query processor. that was one release, and that was SQL Server 7.0. And we also put a down payment on the whole reducing, cost of ownership. Back in the day, you'd load your database, you'd build your indices, and you had statistics, and the optimizer, based on the statistics, would choose the index. And then as you updated the database, the statistics got out of date, if you will, and they would, the optimizer wasn't always picking the right plan. And we did a simple thing. We just would update those automatically. It was revolutionary at the time. But I remember going home one evening, and it was Pennzoil was the customer, and they'd put 7.0 in a beta parallel production kind of environment. And I came on Sunday morning to check things, and I got three, my voicemails flashing, and I had 3 messages in succession from the CIO of that company. Loaded the database in 7.0, running queries, performing poorly, call me. Great. The database, it's 2 hours later or something, he calls back. Continuing to run queries, things are improving, what the hell's going on, call me. And the last one was, it's exceeding all performance expectations in previous leads. What in the hell is going on, call me. And so that was
awesome.
That was sort of 7.0.
All right, let's move on to 2005, 2014, and let's listen to what the folks in the lab had to say about that.
2008 R2 and Project Liberty, we actually managed to scale across kernel groups. We have our Titanium release on big machines like Superdome, 256 processors.
For us, it was all about just fixing 64-bit bugs, so it was a death march. I don't think anyone has any great memories of it.
Also in SQL Server 2008, which was my product as a PM, I really like the idea that we released R2. I'm really lobbying to get that back.
In the early days of SQL Azure, we were really excited to get our machines. There were 6 core boxes with 12 gigabytes of RAM on them. And now we have boxes that are 10 times that big.
I remember when I first started working on the cloud, I'd give presentations and the room would have 3 or 5 people. Now, the rooms are jam-packed and it's standing room only.
I've been working here a long time, and I'm actually more excited now than I have been any time since I joined. The stuff we're doing now to fundamentally explode the myths about the limits of SQL is just wonderful.
All right, Ted, you're obviously going to have to comment on R2, but more importantly, tell us about the themes of 2005 to 2014 timeframe.
First off, I'm just delighted to be back. I was remembering this morning when they came to me and they told me Paul was going to be transitioning, and they asked me a question, basic IQ test: do you want to run the SQL Server business? And I will tell you, if somebody says, "Hey, come run the business around the world's most popular commercial database," you should say yes. And it was the ride of a lifetime. I was also remembering, it was either you or Spiro, but we were going to announce to the team, I was going to get introduced, and one of the last things you or Spiro said to me was, "Hey, don't screw it up." So, number one for my era, don't screw it up. Because I think the thing I walked into was an incredible team, which it is to this day. Number one, an incredible culture. I think one of the things I always remarked about the SQL Server team is just this maniacal customer focus, right? Understood who they were, and then this just belief in the excellence. You got to be great at the craft of engineering, which I believe is also true to today and why they've been able to embrace cloud. Then the third thing is the strategy. Don't do what the others are doing. Don't be complexity kings like the folks in Redwood City. Do something different. TCO was something they just didn't want to embrace. And that's what I walked into. So don't screw it up. Continuing our progress in the enterprise, which at that time was a lot about taking mission critical workloads. And so, everybody goes on in 2012. I think this was also the era where finally, memories had gotten big enough we could rethink things. And so whether you talk about the column store and all the places the column store showed up, whether it was in analysis services or in the relational engine as an index type, or even on the client Power Pivot, And of course, Hackathon. And then, of course, then we had to be there even for your scale-out data warehouse, so getting into the scale-out data warehousing space with parallel data warehouse. So enterprise was one big theme. 2008 R2, I love the prodding on the branding. It's just fantastic branding. One of the things we were about, though, is trying to get releases out more often. We were pretty happy we got out 2008 in 3 years and 2008 R2 in 2 years. The anchor of that was another great branding, Managed Self-Service Business Intelligence. Where the column store met Excel with Power Pivot, SharePoint, like how are we going to enable lots more people to use BI? And then, of course, there was this little thing called the cloud, which...
Oh, I got a surprise for you.
Okay.
Do you remember this?
That's great.
It's the cloud. We are all in.
The cloud, we're all in.
The cloud, we are all in.
The cloud.
The cloud.
The cloud. We are all in.
We are all in.
We're all in. We're all in.
The cloud, we are all in.
The cloud, we are all in. We're all in. We're all in.
The cloud.
We're all in.
We're all in.
All in.
All in.
All in.
We're all in.
Remember that?
Yeah, that was another IQ test. When you saw Steve and he said cloud, you said all in. It was, it was a big shift for us. We had a bit of an innovator's dilemma problem there. You're the best of the world at something. You got more than enough work to do for your resources just in continuing to deliver a great on-premises product. And you have to get after the cloud. And it's way different. Like you got to think about different things. You're not just thinking about defects. You're thinking about quality of service. You're even thinking about cost of goods. Different delivery model. These are, of course, buzzwords, but, continuous delivery, DevOps, and then, of course, we had this problem where we really weren't interested in having two relational engines and forking the code across now cloud delivery and on-premises delivery. And I think one of the things that's great to see is just, how it's all evolved. And embracing those things just makes you better. I was actually reading the recaps from yesterday's Keynote, and I was interested to see in one of them, and I'm paraphrasing here, one of them said, hey, now that Microsoft has to run this thing at scale, they're doing a way better job actually delivering features that really matter to us. And I thought that was a really cool thing to see.
That was pretty cool. All right, Rohan, you're standing in the legacy, taking over now. How does it feel?
Yeah, dude, no pressure, right? It's, for me, it's so humbling and it's such an honor. I think I joined the team during Paul's time, and so for me, it's being here, sitting next to them is, for me, they are like the John Bon Jovi, man, for me, right? So it's a huge, huge honor to be sitting next to them. I do remember a couple of things, right? The first thing is when Paul, on I think it was his last day, sent an email to the entire team. I was just a junior engineer, down in the ranks, about like what he'd learned and the points that the future leaders should remember, and he just sent it to the whole org. That email is still printed out and it's on my desk. And it applies to this day. Like focus on the ISVs, focus on the customer. TCO always matters. This is how we are different. And there's just 8 or 9 bullet points, and literally anytime there is just a bunch of confusion around strategy, I always sort of go back and say, okay, like it just helps me get a good frame around thinking about that. So thank you, Paul. I don't know if you remember that, but
I do remember that.
You did send that email, and it's just a fantastic recapture. I think you just keep that in the time travel thing.
Yeah. That was a whole book. It was just 2 pages.
Yeah, and the don't screw it up part.
Don't screw it up.
Well, don't screw it up. And of course, a lot of my getting into some of the more senior ranks was under Ted. I'm very, very grateful for the opportunity, of course. And the one thing I do remember is Ted being very introspective. Every 6 months, he would sort of come in front of the entire team and share his commitments, and was very, very transparent about the challenges and the thing that he was thinking through. I think one of the most important decisions he made during his tenure was the Rock to Core transition, and we were briefly chatting about it. I mean, that has had a huge impact. And whenever you make a change of that magnitude, there's just, there's lots of times when that can get totally messed up. And very, very thoughtful, laying down the principles, and that's one of the things that I learned from Ted. and that I try to sort of hold on to this day. So I mean, so thank you so much. I think it's a huge part of SQL Server success, and where we're going with Azure Data All Up has been built of 25 years of hard work and dedication, very strong leadership. The team, like Ron, Paul, and Ted have said, it's just been fantastic to watch, and hopefully I'll be able to do a little bit of that too.
Well, we couldn't have done it without them. PASS and the community. You've been the foundation, the sharing, the networking, the helping each other. So from the bottom of our hearts, thank you. Thank you to all of you. So,
Thank you.
Thank you.
Thank you.
So after the keynote, we'll be out front if anybody wants to come and say hi, but we'll leave this little video as we say goodbye, and thank you very much.
Thank you.
Thank you.
Congratulations on 20 years of PASS. Professionally, I grew up with SQL Server.
I've been in tech for about 40 years, and I've never seen a community so passionate about helping each other as the SQL community.
I even met my husband at PASS Summit 2011.
Happy 25th anniversary, SQL Server.
Happy 25 years anniversary, SQL Server.
Happy 25th birthday, SQL Server.
Happy 25th anniversary, SQL Server.
Happy 25th anniversary, SQL Server.
Happy 25th birthday, SQL Server.
Please welcome to the stage Raghu Ramakrishnan.
Hello, everyone. So, it's a real pleasure to be here, a privilege. I began my career many years ago at Wisconsin as a professor, and for 20 years, I was part of this community of SIGMOD VLDB, the academic and research communities. And it takes a community to raise a student. Then, some years ago, I went to Yahoo, where I worked on Hadoop, NoSQL systems, and learned the power of open source. There, the community is, in many ways, where all the action is, right? And I also learned the power of machine learning, the kinds of things we used Hadoop for, personalizing web pages. A user comes in, you've seen them in the past, you know what other users like them are doing. There are millions of them at any given point in time. There's a real opportunity to learn from all of that and tailor their experience. But the thing that I learned, while all this can be powerful, what makes it magical is to bring all this together. When you can bring the power of inference to bear on the data that informs your most important decisions, that's when amazing things happen, okay? And that brings me to the next stage of my journey. I came to Microsoft 6 years ago, and ever since I've been like a kid in a candy shop, right? There's this amazing SQL Server ecosystem that you just heard about that you guys are the heart and soul of, right? And I really, really appreciate what a community can bring to the table and what you bring to this table. Thank you. So I'm very sincere when I say this is really humbling, a real privilege to be able to speak to you. And at Microsoft, there's something else I discovered. Not all of you may know about this, but Rohan mentioned this yesterday. Internally, we have a diversity of data ecosystems. The internal lake is arguably the biggest on the planet. He mentioned that we have 10 exabytes of data. But did you know that every single day, we do over an exabyte of I/O? I mean, where else but at a place like Microsoft do you have this incredible constellation of technologies, activities, people? Speaking of people, this talk simply would not have been possible without the help of some amazing guys. Christian, the architect behind Hyperscale, and earlier he was involved in Hackathon. He's so good, he reads SQL queries upside down, apparently. Naveen is the engineering manager for Hyperscale, and Peter I almost didn't make it here in time today because of the traffic. He was my hot spare. I mean, without these guys, this talk simply would not be there. All right. So on to today's discussion. First, I want to share with you my thoughts on what we are seeing all around us in terms of the changing landscape. I also want to share with you a vision for all this and its implications for data management, how the SQL Server you know and love is evolving. And I stress this is a vision, maybe not quite the kind of vision you had after the past party last night, after all this Seattle, but nonetheless, a vision. What that means is not all of it is down in shipping code, but hopefully it gets you thinking. The rest of the talk, the bulk of the talk, is actually grounded in terms of what is shipping, or will be shipping soon as part of hyperscale. And many of these also ship as part of SQL Server 2019 and beyond. All right. The first thing, and it's a tectonic shift, it's the cloud. And the cloud changes the way we think about pretty much every aspect of building a database system. First, the compute. It's elastic on demand, right? Similarly, data. You can get storage elastic on demand, pretty much unbounded amounts. The joker in the pack, all of this is connected through a network. And the latency induced by the network really extends something that we understand very well. If you squint a bit, it's buffer pools on steroids. Okay? The other thing, we are a victim of our own success. Data is exploding, and the kinds of things people want to do with it, exploding similarly. And that means everyone wants to be a database system now. Okay? This, while it's very grounded in the fact that the surface area of what people want to do is so broad that no one system can do it all, it creates problems. We'll talk about this. So let's start with what the cloud implies for us. Obviously, we need to find ways to do more than sling a software stack in a VM and let it rip, right? We need to natively leverage things like elasticity in compute and storage. At the same time, there are some problems that have been long-standing. We now have an opportunity to address, perhaps. Size of data operations, restore, backup, recovery. Can we make these largely independent of the size? That would be amazing. You heard about accelerated database recovery yesterday. Lindsay actually gave you a demo. Today, I'll tell you how we do this, okay? The other thing, 4 terabytes is so small. We really want to see much bigger scales. And whether we want to see it or not, trust me, they're coming, right? So can we do all of this? And the one challenge we face, we need to be able to deal with network latencies. But then we are database guys. We know buffer management. We know memory hierarchies. We'll figure this out. And I'll tell you how. Let's look at size of database operations. They're here. We want them to be here. More in a bit. Recovery. This is a real pain. And talking to customers makes this abundantly clear. 60% of customers have seen something go down and take over an hour to recover recently. We have to address this. The network. For those of you who are not already familiar, let me quickly illustrate this. On a local SSD, access times are around 150 microseconds. If you are on the same TOR, the same T0, there's about another 40 microseconds added. But then you put a bunch of these on a ring, right? And now it's 2 hops. This becomes, a couple of hundred microseconds. Similarly, a T2 recursively adds another 100 microseconds or so. And if you now think of a region, it's a ring of these in turn. And these zones connected together comprise a region. This roughly is a modern data center, right? Okay, happiness, what does it mean for us? In a nutshell, you can squint and think of all of this as simply defining notions of neighborhood for your data, right? Adjacent, essentially on the same SSD, same machine. Near, within the same T2. That means it's 300-400 microseconds away. Far, this means inside an AZ, about a millisecond away, or maybe inside a region, which is at another millisecond, okay? This is what you need to keep in mind. Now let's talk about the second issue we need to address. Silos, relational data, OLTP. We'll hear a lot about this today. You're familiar. The close cousin, warehouse data, right? But the underlying workload is vastly different. So everything, the way you do transactions, the way you think about the secondary structures you have for accelerating queries, all of these you tune differently, you even build differently. The lake, well, here really you're optimizing for massive scale and cogs. The files are immutable, not much of a transaction system, really. But the plethora of analytic tools here is large and growing. When you look at all of this and why it came to be, plain and simple, people are doing a whole lot more with their data. The requirements are different. And so to build best-of-breed systems, you have come up with these bespoke silos. And frankly, I don't think there is hope to build one single system that does it all well, okay? So what are we left with? Silos do create problems. You can try and hide this a little bit through federated queries, but while that's general, it's often not efficient enough for what you want to do. So you end up having to move data across these systems. That introduces latency. It introduces copies that you have to manage, especially with governance becoming an increasing problem. It complicates life. Can we somehow break free of data silos? Right? To answer that, let's take a look at what a database looks like. Generically, a database has two parts to it. There is the compute part of the stack, where you come in, issue queries, issue updates. On top of that, you have reporting, business intelligence tools, applications. Below that, you have the underlying data, and you have the state management when there are multiple concurrent attempts to update this data. Okay? The details of how these are implemented are complex. You have to cache data to hide various boundaries. You need to think through how you will do transaction management, how you will provide that view of a serializable sequence of changes. You'll need to think about recovery. What happens when something fails, right? How do you get the database back to a consistent state? And the details of how you do each of these may be different for different workloads. But at the end of the day, all of that I call state management, okay? So if you squint, most database systems fit this pattern, right? In some cases, one or more of these component functions might be trivial or complex, but they fit this pattern. And when you think about a cloud-native design, as you will see later today, we're already going to separate the state, the storage management from the compute, okay? Given this, can we kill two birds with one stone? Can we somehow do this planning for a future where we not only optimize for the cloud, we break open the silos. We allow the data in any one of these systems to be accessible to the others at a much deeper level than top-level query federation, right? Again, I stress, I'm not saying you're going to build one storage and index management layer underneath, one storage management underneath to serve them all. Maybe, maybe not. These could be different. The question is, can we open access to other heads when we build one of these stacks? If we can, it would be revolutionary. For example, if you're thinking of your dashboards, they can connect directly to data in your OLTP systems in the most efficient way possible. If you want to do queries using Spark or other tools on your lake, yeah, they can connect directly to data in your OLTP systems, right? Or your DW systems. Machine learning and training. Remember, to make it magical, you need to bring it to bear on your most valuable data. Mostly that's in your OLTP systems, right? This is profound if you can pull it off. So can we? Well, let's start by looking at OLTP systems, top to bottom, in a lot more detail. In many ways, if you can do it here, you should hopefully be able to replicate this elsewhere because this is hard, right? Asset transactions, lots and lots of transactions per second, and you want incredibly low response times, okay? State management is challenging. And the design targets we have are ambitious. 4 terabytes? No. Let's make it large. In fact, let's make it infinite, okay? I mean, again, yesterday you heard Lindsay inviting you to try a 300 or 400 terabyte database, right? We have tested it to over 100 terabytes. Availability, we want to add an extra 9, and I'll tell you some of the ways we think we can do it. Constant time operations, even when traditionally the time has reflected the size of data. So if you think of upsizing, downsizing, adding a read replica, restoring after failure, these typically take minutes or hours. We want to do all of this in under 5 minutes. And in fact, you saw some demos. Recovery, we want to be under 10 seconds, regardless of data size, regardless of the longest running transactions. So while doing all of this, what about normal performance? We want to do better than what we can do today in premium databases, right? Most importantly, the design allows us to factor a bunch of things. If you look at backup, recovery, a lot of this today competes for CPU with the CPU serving the actual OLTP load. By separating, you can scale these operations, do them in the background, really make things a lot more seamless, right? There's also a lot of flexibility in how you set up primaries and secondaries. We'll come to all of this. Okay, the most important part here, the name, okay? The marketing called it hyperscale, but if you heard Dave DeWitt's great talk about hackathon, you know we like Greek names, right? So we went looking for a Greek name, and it hit us. Man, Socrates is a database guy. I mean, think about the Socratic method. He just walked around asking queries, right? So the first PhD. And that's not just it. He had some really deep things to say. Not that. That's what he meant to say. Okay? And you guys, your database administrators, many of you, you know what that means, right? You want to tune for a mix of reads and writes. He was one of us, guys. He was one of us. And in case I haven't convinced you, look at this gem I dug up. Apparently, not much has changed since 400 BC. All right. So now let's move on to other things. Technically, as we get into this project, there are a few themes that I would like you to watch out for. First, separation, compute, storage. This is actually well understood by now. If you really want to take advantage of the cloud, you better figure out how to architecturally separate how you store data from how you allocate and leverage compute. This is not new. We have seen demonstrated value already in SQL DW, Cosmos DB, Azure Data Lake, our internal data lake. Our competitors do it, right? What we're doing here is to really bring this to bear on OLTP systems, and I'll tell you how. Oh, sorry. There's a really important new insight, though. When thinking about OLTP, the log is the beating heart of your system. This is where you establish quorum. And the performance characteristics of the log are profoundly different from most of the rest of your system. So we're going to separate that as well, okay? This allows you to simplify the architecture. It allows you to scale the log, taking into advantage its unique characteristics. Lots of goodness. And the network is simply job security for database people. Memory hierarchies up the wazoo. Okay, let's go through the journey here. Once upon a time, there was a single node database. You put that in a VM. Life is good. Okay? Your latencies are low, your IOPS are high. Life is wonderful. But what happens if a VM fails? Oh, well, let's do head-round replication. Have a quorum of 4 nodes, okay? This will do it, but the network hops for quorum added a couple of milliseconds of latency. Networks slowed down the IOPS, again, by a factor of 3 or 4. And the storage footprint, since every database here, each of these 4 has a full copy of the data, it went up by 4x. And while that's okay, what happens if the data is larger than 4 terabytes? Because the amount of data you can have here is limited by the largest SKU, which let's say is 4 terabytes. Well, you can get around this if you make your data remote. Put the data in remote storage. If you do this, okay, you can have all the data you want. Not all of it is in the primary or in the secondaries, but you can pull in data from the remote storage if it's not there. But IOPS go down the chute. You still have the data that you have in the primary at each of the secondaries, right? And this can and should be improved. In particular, you can't live with this level of I/O performance. Okay? We know how to deal with that for data. The buffer pool extension, which you're already familiar with, right? You have a file on the local SSD where you cache a bunch of pages that either were in the buffer pool recently or have been used a lot. Okay? Clean pages. This is good. The cache hit ratio, if you find the right pages and keep this high, performance is pretty good. But there's another problem. If one of these nodes goes down, the time to bring it back to a point where the local storage reflects all the previous caches is long. Okay? So how can I improve recovery time, reseeding time? You make the buffer pool extension resilient, right? What does that mean? Let's go talk about this. As I said, the buffer pool extension, this collection of pages that you expect to see hit often, you write this in a file in your local SSD. You keep track of the contents in a main memory hackathon table, right? You remember hackathon, and there's this great keynote David gave. So you also have, a list of free slots in this buffer pool extension. And the idea is simple. You intercept reads, and as long as the page that is requested is either in the buffer pool or in the buffer pool extension, performance is just basically local. Similarly, on writes, you make sure that when you have clean pages that have been used often enough based on your policy, you save them to the buffer pool extension. What happens when something goes wrong? When something goes wrong, the buffer pool extension, the SSD part of it, survives, right? The buffer pool itself is wiped out, but the hackathon part that keeps track of making sense of what's in the buffer pool extension, that can be recovered very fast, and you're back in business, okay? So let's come back to our story. With a robust local buffer pool, you can take care of reducing or masking the latencies on data reads and writes. What about log reads and writes? And really, we'd like to get beyond direct attach. The key here is going to be somehow to get to a world where you have a shared log, okay? You want to abstract this as a service. So not only the primary, but also the secondaries, rather than having local logs, they rely upon this shared log service, okay? And if this can be optimized, and we can, I'll tell you more. And if this can be made to take advantage of the cloud to be unbounded in size, all kinds of goodness follow, okay? Notice that in this picture, you still have as many copies of the data in the primary as you have secondaries. We'll come back to that. Given the fact that the log establishes quorum, it seems there's no reason to have everything replicated at every secondary. No? Almost true. Not quite. The tempDB tables have information that's relevant to concurrency control. So here's a news flash for you. When you heard about Hackathon a couple of years ago, the main memory Hackathon database used MVCC, timestamp concurrency control. The rest of SQL Server relied upon two-phase locking. Gradually over the years, we have moved to where it's pretty much MVCC across the board, right? The versions of recently modified records are held in the tempDB. There are many reasons for this, right? Constant time operations for backups recovery, they're a big part of the story. MVCC helps you. And when you have data that's very large, so not just data small enough to fit in memory, but data that's so large that these recovery times, backup times are a big concern, you go towards MVCC. So today, for the most part, we are relying on MVCC. And the persistent version store essentially cleans up how we keep track of versions. So rather than do this in the tempDB, which is locked into the individual database that's running in the primary or in each of the secondaries, we make this also a shared structure by essentially making it part and parcel of the classic, the main database, okay? The details, in-row or off-row representations, diff or full copies, these don't really change, okay? But PVS essentially takes the version history of recently modified records, puts them into the database. And now with this, let's see where we are. Let's come back to log-based quorum, right? All kinds of options open up. First, you can in fact fly with nothing in particular at the secondaries. In fact, you have a lot of flexibility. Let's go look at that. First, if you wanted as much seamless transition as possible, if a primary were to go down, simply have a replica that's a hot spare. And not just a hot spare, that can serve reads too, but has all of the data that's in the primary, okay? This is one mode. When a change happens, it happens still only at the primary. The primary makes the changes, saves them durably, uses the log. We'll come to this part of the story in a moment. And the secondaries use log apply to keep their copies consistent, okay? I'll come back to this in more detail in a moment. The second thing I want to point out here, what's in the different compute machines can be wholly independent. In fact, in this example, a large database is being sharded, right, across the secondaries. This means you can get scale out for read workloads very cost effectively, right? More, the secondaries can be deployed in regions that are further away because they don't necessarily get in the way of your log commit on the primary, right? So all kinds of goodness. The best thing, the changes in the compute are highly localized. They're really in the file manager portion of the code. For us practically, this means many of these changes work seamlessly with the versions of SQL Server running on-prem already. But also down the road, as I hinted earlier, we want to get other engines to be able to access the underlying data seamlessly through the same low-level interfaces. Making that interface area as small as possible, that surface area, helps in this regard. Back to the story. shared data. If you were to share all of the data by writing it to remote storage, as I said, the performance here, even with RBPX, can be improved further. Because what happens if you have a miss, if the data you're looking for is neither in the buffer pool nor in the buffer pool extension? You go to remote storage. Well, can we do better? Yes, you can. And it's fairly straightforward how to do this. Imagine that you have a sharded collection of machines that act as another cache of the data, this time segment-oriented storage. So if you have a 100 terabyte database, and each machine you want to devote to this has 1 terabyte of local SSD, have 100 of them. Shard your data across it. And when a change happens, it happens solely at the primary as before. The change is somehow committed through the log. And all of these page servers track the change. They do log apply and keep up. And when a request comes through, the page servers, which may be behind, can recognize this and catch up, deliver the data you need. We'll see the details in a few minutes. But the bottom line, when you look at this, it comprehensively addresses some of the latency issues, the throughput issues associated with masking the data. All right. Let's look at the query and update flows in the picture I just showed you. So if you look at what happens when an application issues a read, you look in the buffer pool of the SQL Server instance running at that node. Then you look at the buffer pool extension. And if it's in neither of those places, you look in the page server. If the page server is behind, it applies the updates from the Xlog service. But there you go. In normal mode, you never go all the way to Azure storage. Okay? Same thing if you were to read from a secondary. On inserts, when you make a change, again, only at the primary, right? This makes changes both locally and again to the log service. Over time, those inserts, through log apply as we described, affect what's in the page service. In a nutshell, we have established a tiered cache. And if you look at this memory hierarchy we have established now, there's local main memory. There is the buffer pool extension, which is local SSD, right? In terms of the terminology we set up earlier, these are adjacent. Then there is near SSD, which is in the page servers, right? And lastly, for storage, which is Azure storage, okay? Oh, a couple of points maybe I should make here. This architecture has some really nice advantages that may be not so obvious. The actual business of backing up the log is offloaded to the implementation of the log, which I'll get to. Sorry, there is no backup, there is destaging. We'll get to that. If you take the page servers, the backup, the snapshots, the restore, that's happening in this bank of servers, which is separate from the compute servers that are dealing with your primary OLTP load, okay? This is huge. Further, if there are failures, many kinds of failures can be masked by this architecture. If you go to the page server and the page server tries to write to Azure storage and that network connection is flaky, if that fails, the page server can simply remember this and get back to you so you can continue, okay? Later, it can go back and hopefully the network flakiness has gone away. It can redo that write. The layers of indirection here give you many opportunities for retry. And in a cloud architecture, retry is like Control-Alt-Delete, okay? It's the magic tool that you use over and over again. All right, the Xlog service. So what we have done essentially is to take the log and abstract it. So let's go look at the log. You're very familiar with the pain that comes with doing log management in a traditional on-prem setting. The log is an expensive device because you really want high performance. It's in the critical path. Typically, it's a circular buffer. And the challenge is, if you have a large transaction or a long-running transaction, you have a problem, right? Because you start eating your tail. And to avoid this, you have to constantly keep backing up the log. You have to constantly keep writing checkpoints, okay? And both of these are competing for CPU cycles along with the OLTP workload you're trying to support, okay? Further, because it's a circular buffer, the hot point of activity, the tail of the log, keeps shifting physically in the device. The entire device, the entire storage real estate associated with the log has to be high performance. This is expensive, okay? Bottom line, life is not good. And we're going to make it better, ostensibly with this magical Xlog service. So what's the intuition? Turns out to be really simple. Imagine that your log were infinite or unbounded, if you want to be a bit more precise. The log is the database. It reflects ground truth. When something is committed to the log, it is so, okay? If this log could not only be unbounded, but the moment you write, you could somehow say, yeah, someone in there is making sure they write enough copies in enough places, so I don't have to worry about that log ever being lost, right? No backup is required. And these are essentially the characteristics of cloud storage, okay? The challenge, of course, is cost. We'll come back to that in a second. The intuition in a nutshell, the hot part of the log is the tail. And this region is where you need to spend dollars on high-performant memory. As it fills up, you can keep destaging into an unbounded, cheaper tier of storage, okay? That, in a nutshell, is the intuition. You can take advantage of the highly skewed access pattern for a log. The Xlog service manages this, okay? Let's look at this in more detail through this architectural diagram. All updates still happen at the primary. And when you write to this log device, which I have denoted here as the Ultra SSD volume. This really SSDs in a quorum ring with RDMA, super fast. Essentially, a write to that means you're good, and it's fast. Today, 2 milliseconds, we expect it to get much better. That volume, that device, is read-write mounted on the primary, and there are also one or more Xlog VMs for the service where this is read-mounted, okay? Let's go look at one of those Xlog VMs. Those are there to speed up reads. If you want to scale out reads, if you have tens or even hundreds of nodes trying to read, you want to make sure you can serve those reads fast enough. So here, you essentially have a caching hierarchy again. The data in the log, you have in each of these machines a memory cache, which is the most recent changes, an SSD cache, okay, slightly older, the source of truth, the mounted Ultra SSD volume, right? And even this, remember, is getting destaged as it fills up to disk. So ultimately, some part of it maybe not on the Ultra SSD part of storage, but in zone-redundant Azure, standard Azure storage, okay? When a request comes in for a log page, the log broker figures out how to search this hierarchy and find it in the closest location and deliver it back. Most of the time, it's incredibly fast. It just finds it in either the log cache or the SSD cache. The destaging service, the destaging component in the background makes sure that all the writes are happening, the shifting of the log contents from the more expensive parts of the hierarchy to the cheaper parts is happening. And as I said earlier, thanks to the skewed access pattern, this comes with very little performance hit. Incidentally, most of the CPU cycles here are spent by the log broker, the guy that serves the reads. So if there are more reads, scaling it up is pretty darn easy. Have more of these. Okay. Resiliency. If you want to be even more paranoid, and you're willing to accept a little more latency, another millisecond or so, you can have a copy of this whole log infrastructure, right? The SSD volume, as well as the ZRS part and the destaging logic, in 2 AZs, availability zones. Okay? That's a configurable idea. All right. Now let me tie all this back to our original context. Okay? We talked about hyperscale in great detail. And the context I gave you earlier, can we not only optimize our storage and state management hierarchy to take full advantage of the cloud, but do so in a way where we open up the data to other independent query and analytic capabilities, right? Let's see how this architecture can serve as a foundation for that, how it helps with that. So OLTP, DW, let's focus on these. If you look at this picture, it's almost the same picture we discussed earlier. There is the OLTP primary, but rather than the OLTP secondaries, I have snuck in the DW compute. The point here being, the DW queries are not going through the OLTP query head. They're using the same interfaces. They have access to the same state management underneath. Now, keep in mind that the primary workload here is still OLTP, right? And so the whole memory hierarchy you heard about is tailored towards that. The whole logic, the trade-offs are tailored towards that. But the DW application can now directly access a copy of this data. If it wants to make additional copies, if it wants to reflect this in its own stack, those are further things you can do. But step one, the silo is open. What can we do with this? The opportunities are huge, and there's a lot of work to do as well. But this is what I meant earlier when I drew these cryptic diagrams, right? So the world we would like to get to, you do OLTP in the best possible way. You do DW in the best possible way. But the data underneath is mutually accessible. You want to run Spark on some combination of your OLTP and lake data, go for it. You want to run a DW query on the lake on OLTP as well as the DW data, go for it, right? And you should expect performant behavior, right? This doesn't mean you'll never have copies. I mean, after all, even within a single SQL Server database, you have, let's say, a clustered index. The moment you create a covering secondary index, de facto, you have a copy. These are decisions DBAs make all the time, right? We just want to give you the ability to make these kinds of holistic choices across silos, not just within a silo, right? At the end of the day, it's still going to take intelligent design trade-offs, but we want to make it possible. Okay? All right. So to summarize, our primary goal in designing hyperscale was to deliver enterprise-grade performance on OLTP workloads, and to do it in a way where you could scale costs for each component of your workload independently. If you have lots of data, then really the storage underneath is where you're spending more money. You don't necessarily pay for extra compute. If you have a relatively small data set, but very hot lots of reads, writes, then you pay for the compute tier, right? Similarly, the cost of the log reflects changes, updates, right? And this orthogonal factoring of the architecture allows us to transparently architect the cost to reflect these different dimensions independently. In doing this, I hope I waved my hands, I acknowledge that, but I hope I at least shared with you some kernel of how we are thinking about opening up the silos, not by building one giant monolithic system, but rather creating possibly a future data ecosystem where many tools can play in one large lake rather than in walled gardens. And as things like governance become more and more important, right, when you need to have holistic access control, provenance, policies for governing your data, as database people, we understand this. Not everyone who's working in a lake necessarily gets it. It is super important to have a holistic view of every single touch on your data and what's done with it. And that becomes incredibly hard the more silos, the more walled gardens you have to deal with. So can we put all this together and create a single pane of glass where an administrator can have a 360-degree view of all their data, whether it's in an OLTP system or a DW system, where a user, an application, dashboard can essentially write their code to touch all the data regardless of where it is instantly, right? Frankly, it's an exciting time to be in this field. And I hope I've shared some of that sense of excitement. I'm having fun. I hope you will. Thank you.